Welcome back to video number 9. Our goal for today, given a piecewise function, you will be able to set up a table of values and graph. All right, ladies and gentlemen, today is all about piecewise functions. Now, these are probably one of my favorite functions to graph, and that is because by the end, we are going to be graphing different pieces of different functions, and we're going to end up with kind of a cool design and a cool image. So today we're going to get a little artsy. All right, so a piecewise function. Oops, this is not a piecewise linear, so we're going to cross off the word linear. This is just a piecewise function, so our pieces could be anything. The definition is, given a number of non-overlapping intervals on the real number line, a real piecewise function, so we're going to get rid of word of linear again, is graphed that has different functions with different intervals. Okay, so let's go ahead and take a look here. So here's our function f of x. Remember, f of x is just a fancy way of saying y equals. So if we take a look here, how many functions or how many pieces do we have? Well, this is our first piece, this is our second piece, and this is our third piece. All right, so these are your functions. And then this is the domain that you're going to use for that function. So it's the function, the domain, the function, domain, function, domain. By the end, this is what it looks like. So here's our first function, here's our second function, and here is our third function. So we're going to use a lot of the different skills that we've been working with this year and put it all together today. So let's go ahead and let's take a look at our first piecewise function that we're going to do together. So here we go. So graph the following piecewise function. All right, so if we take a look at our first graph, f of x is equal to, now first ask yourself, how many pieces are there? Well, there's 1, 2, and there's 3 pieces to this function because each piece is a separate line. So piece 1, piece 2, and here's your third piece of the function. Now, what we're going to do is, because every function that we have, we're going to go ahead and we're going to create a table of values here. So since there's 3 pieces, we're going to need 3 table of values. So here's going to be my first table of values, x and y. And the first function that we have here is f of x equals the absolute value of y, but we like to call that the absolute value, or y equals the absolute value of y. Okay, now we have to look, well, where do we want to graph this? We want to graph it when x is less than 0. Okay, so that means we want 0, and now we have to go less than 0. So which number is less than 0? Well, that's -1, -2, -3, -4. Now, did they tell us where to stop? No, it's just less than -0. So that's going to go all the way to -infinity. Okay, now, we actually have to look carefully again. So we're going to go back to our inequality skills. So this says x is less than 0. Is x allowed to be equal to 0 here? No, just less than. So that means this is going to be an open dot on our graph. So remember, we do not shade that in. So this is an open dot. So an open dot. And then since this goes all the way to -infinity, this is going to end with an arrow because it goes on forever and ever and ever. All right, so let's go ahead and let's use our calculators and let's fill in our first table of values. So I'm going to go to y equals, clear it out, and I'm going to go to my catalog absolute value and I'm going to type in x. Now I'm going to go back to my table of values and I'm going to start plugging in what I know. So 0 is 0, -1 is 1, -2 is 2, -3 is 3, -4 is 4, and so on. Okay, so now I'm going to go to my graph and I'm going to graph that. So my first point is 0, 0. Now remember, that's going to be an open dot. We're not allowed to be equal to that, but that's still our first dot. And then we go -1, 1, -2, 2. And these are all closed dots because we're allowed to be equal to these dots. Okay, and now we're going to go ahead and we're going to connect those with a line. So I'm going to start at 0, 0, and now I'm going to connect them. And it ends with an arrow because it goes on all the way to negative infinity. Now if I hit the graph button, we can see, all right, we just graphed a piece of this function. All right, so now let's go ahead and let's try our middle piece. So our middle piece is going to be y is equal to 2. Now we have to make a table of values. Now look at the domain that they told us. We're going to go from 0 all the way to 4. So 0, 1, 2, 3, and 4. Now let's look carefully at the two endpoints that they gave us. 0 is less than or equal to. So are we allowed to be equal to the 0? Yes, we are. So this is going to be a closed dot. So closed dot. Then we go all the way to 4. Now is x allowed to be equal to 4 here? Nope, x has to be less than 4. So this is going to get an open dot on our graph. All right, so now let's go ahead and let's fill in the y. So I'm going to go to y equals, clear it out. Now this is the function y equals 2. Now I go to my table of values, and what do we notice about every single y here? They're always equal to 2. So this is going to be 2, 2, 2, 2, and 2. Now we're going to plot, and this is our middle piece. So our first dot is going to be 0, 2. So I'm going to go up to 0, 2, and this is going to be a closed dot, because it says right here we're allowed to be equal to 0. Then we go 1, 2, and these are all closed dots because they're in the interval. 3, 2, and now 4, 2, this is an open dot. We're not allowed to be equal to 4, so that's an open dot. So these are all closed dots in between, and then we just connect them. And now we have our second piece. All right, on to our third piece of the function. So our third piece is right here. It's y equals x minus 4. And now we're going to set up our table of values. We're going to go from 4 all the way to 10 because it says from 4 and it ends at 10. So 4, 5, 6, 7, 8, 9, and 10. Now if you look, it says less than or equal to. So think, is that an open dot or a closed dot? You've got it. That's a closed dot. Okay, and then 10, x has to be less than or equal to 10. Now you're allowed to be equal to it, so that's going to be another closed dot. Okay, so let's go ahead now and let's fill in our y's. So we're going to go to our y equals, and now we're going to type in x minus 4, and then we're going to go to our table of values. All right, and we're going to go down. So at 4, we're going to be at 0. At 5, we're at 1, 6 is 2, 7 is 3, 8 is going to be 4, 9 is 5, and 10 is 6. So now I'm going to go back to my graph and I'm going to plot these. So 4, 0, this is a closed dot. 5, 1, 6, 2, 7, 3, 8, 4, 9, 5, and 10, 6 is another closed dot. So these are all closed dots. And then I'm going to connect them just like that. And if I go and I hit graph, I see this piece right here is the piece of the function right here. Now, ladies and gentlemen, let's take a look. Congratulations, you've just created your very first piecewise function. 1 piece, 2 piece, 3 pieces. All right, let's go ahead. We're going to flip the page over. And I'd like to try another piecewise function. So let's take a look here at this piecewise function. This time we have h of x is equal to. So ask yourself, how many pieces do we have here? Correct, there's 2 pieces. This is my first piece, and this is my second piece. The first piece is your function. The second piece, this is your domain. So domain and then the function. So if we have 2 pieces, how many table of values do we need? Correct. We're going to need 2 tables of values. So my first function, y equals x squared minus 6x plus 10. And then we're going to set it up. Now let's look at our domain. We're going to go from 0 all the way to 5. So from 0, 1, 2, 3, 4, and 5. Now look carefully at your inequality symbols. There's a line underneath, so our point at 0, is that going to be an open or a closed dot? You got it. That's going to be a closed dot. And then if we look here, this 5, x is less than or equal to 5. Since it's equal to, we get to use the closed dot. Okay, now let's use our calculators to fill in the table of values. X squared minus 6x plus 10. We hit second, y equals. All right, I'm going to go up to find my points. So 0 is 10, 1 is 5, 2 is 2, 3 is 1, 4 is 2, and 5 is 5. So let's go ahead and let's graph our first piece. So actually, if I hit graph, I can see I'm going to graph the first part of a parabola. So let's go ahead. 0, 10, all the way to the top, closed dot. 1, 5, remember everything in between is a closed dot. 3, 1, 4, 2, and 5 up to 5. So it kind of looks like, now if we were to connect our dots, we are creating kind of a backwards J. So we're creating a backwards J there. All right, now let's do our second piece. Y is equal to 1/4 x minus 5 over 4. All right, so this time we're going to go from 5 all the way to 9. Now let's look carefully at our inequalities. 5 is less than x. So are we allowed to be equal? Nope, so this is an open dot. Now let's look at the 9. X is less than or equal to 9, so this is going to be a closed dot. All right, and now we're going to let the calculator do the work for us. So 1 divided by 4x minus 5 divided by 4. And now I'm going to go to my table of values and I'm going to fill them in. So at 5, we're at 0. At 6, we're going to be at 0.25. At 7, we're at 0.5. At 8, we're at 0.75. And at 9, we're going to be at 1. Okay, so let's go ahead and let's plot these points out. 5, 0 gets an open dot. 6, now we're going to be at 0.25, 0.5, 0.75, and 9, we're going to be up at 1, and this gets a closed dot. Okay, and now we can go ahead, connect those. So we've now drawn a piece of a line. So ladies and gentlemen, you've created your second piecewise function. Kind of a cool little design that we're starting to create here. So remember, for how many pieces you have, that's how many tables that you're going to create. Okay, so let's take a look at number 3 now. So for this question, it says, which of the function definitions will produce the graph at the right? So this time we're given the graph, and we have to tell which one it's going to be. All right, so I always like to use my graphing calculator to really help me out with this one. So what I need to do is match the functions to the different pieces. So if I take a look, here's my first function, and there's my first piece. So what I'm going to do is I'm going to start by plugging in the first piece into the calculator. So let's take a look, x plus 3, and then I hit graph. So here's my first function. All right, does that match right here? Well, yes, it does. So we've got it. So the first piece has to be x plus 3. Well, this one's x plus 3. These ones are not. So I can go ahead and cross these ones out because I know the first piece has to be x plus 3. Now we have to take a look at the second pieces, which are very different, or we can take a look at the third piece. I'm going to go right to the third piece because this is x plus 4 and that's x minus 4, and that might be pretty easy to match this one too. All right, so I'm going to go ahead first and I'm going to go to y equals, and I'm going to type in x plus 4 and I'm going to hit graph. Well, x plus 4 is this line right here. Look at this last piece right here. Does this match this up here? Well, no, this is down here in quadrant 4 and this is in quadrant 1. So that means this one cannot be our solution. But if I go here, I change that to a minus 4 and hit graph. Now this piece matches our piece there. All right, ladies and gentlemen, we now have your answer there, and I'd like you now to flip to the next page. You're going to go ahead and try this last part on your own. Have a great night, everyone. If you have any questions, come on in tomorrow before school and I'll help you out.